The HS900L can be powered on by pressing and holding the power button for 4 seconds. There are some physical buttons on the sides and bottom of the screen. There is also a shuttle knob. The instrument screen is touch sensitive. The battery level is displayed in the upper left corner of the boot screen. The date is in the upper right corner. The power off button is in the lower left corner. The software version is in the lower right corner. The central area contains 4 sections: guided wave detection, data analysis, file management, and system settings. Click Guided Wave Detection. After entering Guided Wave Detection, there is a menu panel on the left, which includes Parameters, Calibration, Gate, Signal Processing, Data Record, and Channels. The current channel display is Channel 1. This instrument is equipped with 2 channels, enabling switching between Channel 1 and Channel 2. The first step of the inspection is to confirm the specifications of the workpiece to be inspected, such as its length, material, and wall thickness. Primarily, the first operation is to perform sound velocity calibration for the workpiece to be inspected. Manual calibration means calibrating the sound velocity with a predetermined length of the workpiece. You can see a range option at the bottom left of the parameters interface. The range refers to the detection range displayed on the horizontal axis. The length of the workpiece to be inspected in this test is approximately 7,900 millimeters. Therefore, adjusting the range to 8,678 millimeters is sufficient for this inspection. The signal currently displayed on the left is the initial pulse signal. The middle is detection area, and the area behind it is the signal from the tube's end. Our current velocity speed is 4,827 meters per second. The blue gate is our gate B, and the corresponding distance S is 7,764 millimeters. The length measured in this test is 7,900 millimeters, and we need to calibrate the current velocity of sound. Click on the velocity, then click again to adjust the step size below. While fine-tuning the sound velocity, observe the S value corresponding to gate B's represents the length of the signal at the end corresponding to gate B. Adjust till the S value near to 7,900 meters per second. It's adjusted to 7,914. At this point, gate B perfectly covers the bottom wave. For our sound velocity calibration, the current velocity is a value of 4,868 meters per second. Let's look at the signal display supported by our instrument in detect mode. There are 4 types of displays: full detection, radio frequency, positive detection, and negative detection. Next is a PRF button, represents the repetition frequency. For guided wave detection, if it not perform movement scanning, we can set the repetition frequency to 5 Hz, which can be adjusted to 10 Hz or 5 Hz, with 5 Hz as the default. Cycle count represents the number of signal cycles, which is 4 by default and can be adjusted to 4 or 5. The sound velocity after calibration is 4,868 meters per second. The subsequent step is orientation. This test starts from the end, so the default is positive. This is the smooth function interface. and the current detection mode is full detection. The smooth function is currently turned off. Clicking the smooth button to turn it on and off. When turn it on, you can see the signal has been smoothed. Let's check the smoothing effect when the detection mode is switched to negative, where the effect is particularly pronounced. We turn the smooth function off and then on again. What we see now are the signal performances in the on and OFF states, respectively. The current smooth function only applies to full detection, positive detection, and negative detection modes, and is ineffective for the radio frequency wave mode. The selection of detection mode depends on personal habits, with the radio frequency wave mode being the most commonly used. For detection mode, it is recommended to select the radio frequency wave mode. With the smooth function turned off, click the calibration button for the excitation frequency of guided wave detection. The supported range of this instrument is 10 kHz to 150 kHz. This demonstration starts with an initial excitation frequency of 30 kHz, with the adjustment step set to 1 kHz for manual adjustment of the excitation frequency. While adjusting the excitation frequency, you can observe the real-time changes in signal amplitude. At the end position covered by the blue gate, also, pay attention to the area covered by the red gate in the middle. A suspected defect signal appears in this area. When the excitation frequency is adjusted to 42 kHz, continue increasing the excitation frequency. The signal-to-noise ratio of the suspected defect signal reaches a relatively high level when the frequency is adjusted to around 58 kHz. Continue increasing the excitation frequency to find the optimal frequency point for detection. It can be observed that when the excitation frequency rises to 91 kHz, the bottom wave signal attenuates and the defect signal in the middle area disappears accordingly. Then manually adjust the excitation frequency back to 58 kHz. The current 58 kHz is the optimal excitation frequency point for this test. Click the gate function button, and you can see that the end signal covered by the blue gate, B, corresponds to a detection distance S of approximately 8 meters. The defect signal covered by the red gate, A, corresponds to a detection distance S of 3,996 millimeters, approximately 4 meters. Gate A corresponds to the red gate, and Gate B corresponds to the blue gate. You can switch between them by clicking the gate switching button. Click the gate display button to independently select whether Gate A and Gate B are displayed on the interface. To adjust the starting position of Gate B, press and hold the physical operation button to move the gate. You can also double-click the screen to quickly change the position of the gate. The width and height of the gate can be adjusted here, and the functional area is also equipped with a gate wave zoom function. Next, we will introduce the signal processing functions. The first one is average count. The larger the value, the smaller the fluctuation, amplitude of the signal. The second one is correlation count, which is mainly used to process some interference signals, and its default value is 1. The third one is digital filter, which is currently off. Click on the digital filter and then click the physical button on the right to turn it on or off. It can be seen that the signal after the initial pulse has been significantly improved. Digital filter is off by default during the detection process. You can choose to turn it on if you want to process the detection signal to make it clearer. Click Return. The last button is for wavelet noise reduction. It's also turn on/off via the physical buttons on the right. The signal will be significantly improved after turning it on. The following are some signal processing related functions. Perform some optimizations for different functions. Wavelet noise reduction is off by default during the detection process. Turn the digital filter off again. Next step is our data record. Click the data record. Click on Save to store the waveform. Enter a name you can distinguish. Click OK when finished, and the waveform will be saved. The next step is waveform frozen, which freezes the current detection waveform. The next step is waveform comparison. The white waveform generated when the switch is turned on will be compared with the real-time waveform. The next step is the envelope. Record is the monitoring switch. This instrument can perform on-site monitoring. Simply turn on the monitoring switch, then select the monitoring interval in the interval settings. The default is to collect data once per hour. The next step is to take a screenshot. Turn off the envelope and click on the screenshot. Enter a name for the screenshot. Click OK, and the screenshot is complete. Click Save Parameters. You will see options of Save, Without Save, Save Param, Read Param Tour, and Return. Click Save Param to save the current testing process. The workpiece currently being inspected has an ID of 13 mm. You can name it 13 and click OK. Saved successfully. Click Read and select the saved file. No problems. Click Return. Return to the main interface and click Data Analysis. The first is Record Analysis, the second is Report Review, and the third is Return. Click on Record Analysis and select and open the file we just named as 2026-8. Gate Start is the starting point of the gate. We can move the gate start so that gate A moves to cover the defect. The distance shown for the defect on gate A is 3,949 mm, and the distance shown for gate B is 7,764 mm. The width of the gate can be adjusted as needed. Next is spectrum and time frequency analysis. Both of these involve analyzing the signal. Next is the generation of reports. Enter a name for the report and click OK. Then there's a gate waveform zoom. We zoom in on the current waveform of gate A. If two waveforms appear close together, you can turn on the gate waveform zoom function to view the waveform. Click Return, then click Report Review. Select and open the report you named. This is a test report by default. It includes transmit parameters, receive parameters, display parameters, signal processing, and the screenshot we just generated. It can be modified according to the customer's actual needs. The functions below are, in order: zoom in, zoom out, restore, print, and exit. Click Exit. Click Return to the main interface. Click on File Management. On the left menu, the corresponding options are Export, Delete, Select All, Select None, and Save As. The first button at the bottom is Static Storage. The second is Screenshots. The third is Report Files. The fourth is Parameter Files, and the last is System Files. We click these buttons to view the previously saved Screenshot 13. Report File 0 and Parameter File 13. We can click the Screenshot button, select the file, and click Export to export the current screenshot file to a USB drive. The same applies to report files. Click the Report File button, select the files, and click Export to export the file to USB drive. Click Return Physical button on right to return to the main interface. Click the Settings button. First, here is our system time setting. Then, there are the brightness adjustment, interface style, and Chinese-English language switching. The interface style can be changed by color. The default is blue. This is the entire demonstration procedure for heat exchange tube.